Hi, I'm Brett Hodges. I'm a KitOps contributor and the creator of the Python KitOps package, which makes it easy to get all of the benefits of KitOps ModelKits directly from your Jupyter notebooks or experimentation tools like MLflow. I'll be demonstrating that later in this video, but first, for anyone who is unfamiliar with KitOps, I'll provide a brief introduction. KitOps is an open source DevOps tool that packages and versions your AI/ML project into a reproducible artifact called a model kit. Each model kit includes everything teams need to develop, test, deploy, and manage an AI/ML project, including models, datasets, code, and configuration. I found KitOps after seeing some of the challenges data science teams face bringing multi-team projects into production at Fortune 500 companies, most often around security risks and deployment delays. Using KitOps model kits reduces security risks by creating a single, tamper-proof, versionable package for each AI/ML project. All of the artifacts stored in the model kit, the model, the data sets, code, docs, etc., are all digitally signed and immutable. This makes model kits ideal for building a security software supply chain for the AI/ML projects. Additionally, every change to a model kit is time-stamped and includes info about the source of the change. This facilitates automated change tracking and auditing of AI/ML projects. Besides reducing risk, using model kits can help speed up production deployments by easing the transition from Jupyter notebooks and experimentation tools. Model kits make it easy to extract only the artifacts of interest based on a person's role. Model kits are also built on existing standards, ensuring compatibility with the tools data scientists, developers, and DevOps teams already use, like MLflow. Finally, model kits are stored in your enterprise container registry and governed by the same authorization you already trust. Now for the demo. In this MLflow instance, we have an experiment focusing on predicting the quality of white wine. And you can see that we already have a number of runs captured for this experiment. So how are these runs generated? Well, they've been generated programmatically via a Python project I'm running in VS Code. You can see at the top of my demo.py source file that I'm making heavy use of the MLflow package. I'm also using familiar packages like pandas and sklearn. In fact, most of the project's code probably resembles a simplified version of machine learning projects you've created yourself. Glancing through it, you'll see that we're retrieving data, processing the data, and splitting it into testing and training data sets. And then the experiment is run. And as part of that run, we're logging MLflow data like the optimal parameters for the model, metrics like the best score, and even a serialized version of the model itself. And at the end of the experiment, we call the evaluate function, which automatically logs metrics and charts describing how the model performed. Back in the MLflow UI, let's examine the results from the most recent run, named Industrious Loon 433. The Overview tab provides us with the run ID, the optimal parameters, and the performance metrics for the model. And the Artifacts tab contains the model serialized as a pickle file. And it also includes a series of charts as image files and some data as a CSV file. And these provide us with more insight into the model's performance. So let's assume that we want to deploy the model from this latest run to production. But before we do that, we're going to bundle up our model and all of its dependencies, including the MLflow metadata and the artifacts we just saw, into a KitOps model kit. Let's jump back over to our VS Code project to see how our model kit gets created. So back in this code, we're picking up where the experiments run completed. And the first thing we're doing is downloading all of the useful information we want to include from the MLflow run. This includes the run's name and ID, the optimal model parameters, and the performance metrics and charts, and finally, the serialized version of the model itself. With these artifacts and the ones included from this VS Code project, we're ready to build our model kit. I already pointed out some of the Python packages this project uses, but now I want to highlight one more. The KitOps package is a new Python SDK for building and working with KitOps ModelKits. So that's what we'll be using in our code. The heart of a model kit is the kit file, and it describes all of the components that make up a model kit. You can think of this as your project's recipe. So our first step is to programmatically build our kit file using the KitOps kit file class. And you can see in the code that all the components of the kit file are defined. The package name and version, the model, including the path to the serialized pickle file, the code, which references the source file we're looking at now, the data set, the docs, which include a README and a license, but then are extended to include the charts downloaded from MLflow. And next, we're going to use the KitOps ModelKit Manager class to pack the model kit, tag it with a meaningful name, and push it to our registry. Now, I'm using the Josu hub located at josu.ml, but you can use any OCI 1.1 compatible container registry like ECR, Artifactory, or Docker Hub, or others. For convenience, when this code is executed, it prints the contents of the kit file, but the kit file also becomes part of your project and is saved in the project's root directory. So we'll look at it here. As you can see, the kit file contents are saved in YAML format, and it's broken out into the same sections that we saw when we constructed it in our code. There's the manifest version, package code, datasets, docs, and model, etc. What I want to quickly point out here is within the model section, there's the parameters subsection. And it's within this subsection that we've included the relevant metadata about the MLflow experiment and the run from which this model originated. So we have, for instance, the run info, which includes the run name that we saw, the run ID and the experiment ID, the metrics that were captured from MLflow, and also the best hyperparameters. And this information is available to anyone who pulls the model kit from the registry and views its kit file. Now, before we wrap up, let's have a look at our model kit within the registry. This web browser is displaying our model kit registry in the Josu hub, located at josu.ml. I've already logged in, and I'm looking at a list of my repositories, which have been sorted from newest to oldest. Near the top of the list, we'll find the repository White Wine Quality Predictor, which contains my model kit. So I'll click on it. Within my model kit, I tagged it as the latest, which is what's showing up here. And just to the bottom and right is the pull tag link. When I click on that, I can copy this command and run it from a terminal or shell, and this will allow me to download this model kit. I can also send that to someone else for them to download it. The model kit contents section at the bottom right gives me quick insight into which components my model kit does or does not contain. And I can click on the more details link for a more robust view of my model kit's contents. Finally, I can click on the Deploy this model kit tab, and I can package this model up into a basic container right from the Deploy tab of the Josu Hub. I don't even need to know anything about Docker or Kubernetes to do this. As we've seen, by using the KitOps package in our Python code as part of our MLflow workflow, it was quite easy to turn scattered and unmanaged project assets into a single, secure model kit with digitally signed layers ready to be deployed to your container registry of choice. If you'd like to learn more about KitOps, the Python KitOps package, or Jozu Hub, those links are displayed on your screen now. Thank you for watching, and if you found this video helpful, please hit the like button. Have a great day.